Okay, we're going to have a look today at factorising trinomials. Before we do that, I just want us to be comfortable with the cyclical nature of expanding brackets and factorising as a means to check if we're correct. If we were to, for example, expand this term here, if we were to multiply out that bracket, that would become 2x times 4, which is 8x. 2x times minus 3x is minus 6x squared. But let's imagine now that we're looking at this term here, and we were asked to factorise this. Well, we would take the highest common factor of 2x, and then we would put inside the bracket 4 minus 3x. So do you notice how we can go from here to here, and here to here? We can go both forwards and backwards. Similarly, if we were to multiply out this bracket here, we would get to our completed square form, x squared, difference of two squares, sorry, not completed square, x squared minus 9, a difference of two squares. And if we were asked to factorise this, we would then go to here, because that's the same as x squared minus 3 squared. Okay, so we need to be kind of comfortable with this idea, because it's this idea of how it's cyclical as to how we're going to maybe start building up some of the ideas on how to factorise some more complex expressions. Okay, so we know we can go from here to here by expanding, and then similarly, if we work backwards and factorise, we'll put the brackets back in. So let's have a look at a couple of expressions here, and let's see if we can spot anything. Let's imagine we wanted to expand the bracket x plus 2, x plus 7. Okay, so I'm just going to talk through what that would be. So see if we were to multiply that out, that would become x squared plus 7x plus 2x, so that's plus 9x, and then 2 plus 7, or 2 times 7, sorry, is 14. Okay, so there's one example. All we've done there is we've just multiplied out that set of double brackets. Let's just choose another few examples. Let's go x plus 10, x plus 2. Well, if we were to multiply this out, x times x is x squared, x times 2 is 2x, plus 10x, so that's going to be plus 12x, and then 10 times 2 is 20. We'll do another couple. Let's do x plus 4, x plus 5. If we were to multiply this out and collect like terms, we would get x squared plus 9x plus 20. We do x plus 2, x plus 8. When we multiply this out, we would get x squared plus 10x plus 16. Okay, so we've just taken some 4 examples here. I've kind of taken a shortcut of multiplying them out. Okay, so what we've done here is we have multiplied out the bracket from here to here. But because of this relationship here, it holds that if we work the other way, it holds that if we factorise this, it should give us this answer. If we factorise this, it should give us this answer. If we factorise this, and if we factorise this. And what we need to do is we need to examine these a lot more closely and see, can we notice any connections? So what I'm going to do is I'm just going to highlight the numbers here, 2 and 7. Is there anything connecting 2 and 7 with these values here? Well, there is actually, because if we have a look here, let's go a bit smaller. 2 times 7 is 14, 2 plus 7 is 9. Okay, let's have a look at the next one. Let's have a look at the 10 and the 2. 10 times 2 is 20, 10 plus 2 is 12. Let's have a look at 4 and 5. 4 times 5 is 20, 4 plus 5 is 9. 2 and 8, 2 times 8 is 16. 2 plus 8 is 10. Okay, so there seems to be like a connection between these values here and these values here. But let's imagine if, and this is going to be the problems we're going to be dealing with, if we were left with x squared plus 6x plus 5. Well, what would these brackets be? How would I choose them? How would I determine what values to put into my brackets here to make sure that it works? Okay, you might be able to start seeing it already. Okay, so we're going to just say, we'll do 3 examples here. And it'll just say factorise the following. Okay, so number 1, let's go for x squared plus 6x plus 8. So remember when we've been looking at factorising, we've been asking, is there a common factor? Do I have something squared, take away something squared? And you can see in both these, this expression does not meet either of those criteria. I don't have a common factor, I don't have something squared, take away something squared. So that means I'm going to have a trinomial. Okay, this here is referred to as a trinomial. So what we need to do is we need to be able to try and build up this expression into factorised form in such a way that if we multiply it out, we get back to our original question. Notice here that, if I'm underlining these, notice that the two numbers at the end here multiply to give us the two numbers at the end here. Yeah, do we see that? 4 times 5 is 20. 10 times 2 is 20. 2 times 7 is 14. Okay, so maybe it makes sense to, or this is what we generally do to start off with. What we're going to do is we're going to write down factor pairs. We're going to write down numbers that multiply to make the end number. Okay, so what numbers multiply to make the end number? Okay, we could have 1 times 8, or we could have 2 times 4. Okay, those are the two options that would allow us to make 8 if we multiply them. Okay, so we've got two options, but how do we know which one to choose? It's going to be x plus 1, x plus 8, or x plus 2, x plus 4. And once again, if we have a look again at this relationship here, so 2 times 8 makes 16, but 2 plus 8 makes 10. Okay, so we choose the pair that multiplies to make 8, but that adds to make 6. So 1 plus 8 is 9, but 2 plus 4 is 6. Okay, so therefore my brackets are going to be x plus 2, x plus 4. These numbers multiply to make 8, and they add to make 6. If we were to check this, x plus 2, x plus 4, that would be x squared plus 4x plus 2x plus 8, which would become x squared plus 6x plus 8. I've done my check, it's the same as the original question, I know I'm good. Let's have a look at example 2. Let's go for y squared plus 10y plus 24. So step 1, is there a common factor? Nope. Step 2, do I have something squared take away something squared? Nope. So I'm going to have a trinomial. It's going to be y with y. It's not x this time, it's just y. So remember, these numbers here need to multiply to make 24. So let's write down potential options. So what multiplies to make 24? Well, I've got 1 in 24, 2 times 12, 3 times 8, and 4 times 6. Okay, so I've got 4 potential options that multiply to make 24, But remember, we also want to choose the option that adds to make 10. So when we add these together, we don't get 10, we don't get 10, we don't get 10, we get 10. So our brackets are going to be y plus 4, y plus 6. And if we were to multiply that out, we would get back to our original question. Let's do one more example. Let's go for x squared plus 17x plus 30. Okay, so step 1, is there a common factor? Nope. Step 2, do I have something squared take away something squared? Nope. So I'm going to have my double brackets. This is a trinomial. Okay, so it's going to be x and x. Remember, let's see here. These two numbers need to multiply to make 30. So let's write down some options to make 30. I could have 1 times 30, 2 times 15, 3 times 10, and I've got 5 times 6. So I've got 4 options here. I choose the option that when I add them, I get 17. So this doesn't make 17, this does. So therefore my brackets are going to be x plus 2, x plus 15. Remember with our check, if we were to multiply this out, this would become x squared plus 15x plus 2x plus 30, which gives us x squared plus 17x plus 30. It's the exact same as the original question. This check tells me that that's correct. Okay, so your general strategy is to find factor pairs of the end number that add to make the middle number. Thanks very much.